Hey, my name is Victor Zaccardo, and I want to give you a brief overview of my thesis. So, my project is to create an active magnetic bearing to position a catheter, which is not typically how you'd use an active magnetic bearing. Usually use it to suspend a shaft or something. But what I've done here is I've water jet these poles out of electrical steel. I wound all these coils on a CNC mill. Position feedback is by two linear optical arrays, one here and one on the backside for vertical and horizontal position. The tip of the catheter will be painted with fluorescent paint, you can kind of see in the middle, which illuminates the tip of the catheter. To get rid of background light, I put red filters on the linear optical arrays, so it only picks up the red light reflected by the fluorescent paint. Driving everything, I've got a TI MSP430 with a custom PCB I designed on the top there. These knobs are for the set points, vertical and horizontal. So that calculates control action, which is then sent to this transistor array here. Each of the 4 LEDs corresponds to the duty cycle through each of the poles. So right now it's just regulating position. So if I were to tap it, you can see that the bearing regulates itself back to the center. That is driven by a 12-volt power supply. I've got right here, you see it doesn't consume very much current. That sends serial data to my laptop, which runs a LabVIEW program, which plots the top graph as error, the bottom one is control action. So if I bump it here with my hand, you can see that it records it accurately and shows that it's driving error back to 0. One last thing I'll point out is it follows the set point tracking pretty well. So if I change the horizontal set point here, it will drive the catheter further away. We'll bring it back to the center and then move it to the other side. And then back to the center. So, thanks for watching.